Hi, for my project, I'm going to be looking at a problem found in the financial services area, specifically in the area called markets and electronic trading. And it has to do about whether a client is likely to execute a trade on which he's been given a price from the trading desk. So electronic trading in financial markets is very prevalent across all asset classes right now. An RFQ, which stands for request for a quote, is a request for a quote by a client to a bank trader. The hit ratio is the ratio of executions by the client to the number of quotes returned to the client. And this is actually quite low in workflows where our bank provides pricing to smaller banks to service their end clients. Traders spend significant time pricing instruments that are not executed, leading to opportunity costs, lost revenue, and overall frustration. This is an attractive problem for machine learning, where the problem is inefficient workflows and the costs due to the unpredictability of client executions and therefore low hit ratios. Machine learning can help by analyzing historical patterns and client behaviors to determine the probability of an RFQ being executed or not. Traders care because when they execute, they make money. Salespeople within the bank also make money for every trade is executed. And obviously there's a better relationship between sales and clients if the client is continually getting these trades executed. So the problem definition is to predict the likelihood of a client executing a trade on a submitted RFQ, a request for quote. This matters because real-time predictions will help traders focus on the RFQs that are likely to be executed, this thereby optimizing their time and resources and leading to more trades being executed and therefore greater revenue. So some of the success criteria for the project are the expected business impact is an increase in trading efficiency and revenue and a better service to the more important clients. For outcome metrics, we expect an improvement of 10 to 15% improvement in hit ratios. And for output metrics, we're going to look at precision of predicted hits to the proportion that actually hit, recall of actual hits to the proportion of predicted hits, and then to use the F1 score, which is a balance of precision and recall. So the solution concept is a machine learning model predicts whether an RFQ will be executed or not, and displays this result to the trader when the request comes into the trader. The RFQs or the requests will be ranked by execution likelihood and shown in a list format to the trader, with the most likely RFQs to be executed at the top of the list. This allows the trader to easily address the RFQs that are most likely to execute, and ones which are less likely to execute will drop to the bottom of the list. So the validation plan is one to develop a heuristic model. So we will calculate the average hit ratios for each client and instrument over the last 12 months. And we can use this value as a benchmark for our machine learning process. Secondly, to build and validate a machine learning model using historical RFQ data, test the model with live data in a controlled setting, and then integrate these predictions into the trader's workflow, gathering feedback from the trader. The machine learning system design decisions were cloud versus edge. So we're going to go with a cloud-based system. A cloud-based system is better for processing data in a centralized way. It's more efficient and has access to historical data. Offline versus online learning, the choice here will be offline learning. So the plan is to execute periodic retraining on the latest data. Online learning is not required. And then batch versus online predictions. So the choice here is online predictions. So it's very important that when an RFQ comes in, gets popped up to the trader, that there is an immediate response from the model on the prediction about whether this is likely to be executed or not. So some potential risks in production. One, training serving skew. So where we have a mismatch between training data and real-time input data. So the mitigation here is to have consistent pre-processing pipelines between the training and real-time input data. Secondly, data drift. The risk here is that client behavior or market conditions change over time. So it's important here to regularly monitor the situation and then to retrain the model when necessary. And finally, latency. So the risk here is that delayed predictions will impact the order RFQs are displayed to traders, or maybe not even displayed at all, which impacts the trader's ability to decide which ones he needs to work on. So the mitigation here is to optimize the model size and to deploy scalable cloud infrastructure to ensure that we don't have these latency problems. Thank you. That was it for my project. Thank you.